Now let's look at figure 15-10 and run a calculation on a number 4 type conductor. And notice, for example, we're using the percentages of voltage drop to determine the size conductors needed to correct the voltage drop problem for a single phase feeder having the following characteristics. Now we use the same thing for branch circuits as we're using for this feeder circuit, so keep that in mind. And the voltage drop is 3%, voltage is 240, the length is 125, the load is 82.5 amps, and the conductors are THWN copper. Now we're finding the size conductors based upon this voltage drop problem. Again, we're using a feeder 215.2A1 informational note 2. But now if you wanted to do it for a branch circuit, it would just be 210.19A informational note 3, branch circuit equal 3%. Same thing. And when we just, since it's a feeder in step 2 using the circular mill method, we take and see just exactly what would be taken and what we would need when we do the calculation. So circular mill is equal to 2 times K times L times I divided by the voltage drop. So the circular mill then, the rating of the conductor we would need would be 2 times 12.9 for copper. Now, you'd want to keep a note of this, that for aluminum it's 21.2 that we would basically use, but since it's copper, it's 12.9. And these are just constants based upon copper or aluminum. So if it was aluminum instead of copper, you'd put 21.2 here instead of 12.9. So again, circular mill is 2 times 12.9 for copper times 125 feet times 22.5 for the amps divided by 240 times the square root of 3, or 3%, excuse me, that was a misquote. We come up then with a circular mill rating of 36,953 circular mill. So the circular mill rating that we need for 36,953 is a number 4 copper conductor. And if it was 3-phase, the note just tells you to remember for the voltage to tack on 0.866, which you would take 1.732, I think it is, to obtain that value. Yes, that's what you would do. You would take 1.732 and you would divide by 2, and you would come up with 0.866. That would be the correct way to do it. So I'm quoting it correctly to you now. And that's what our figure 15-10 is illustrating to us, using the circular mill method to find out what size wire you would need in circular mill rating.